Okay, students, welcome to my video for 7.3. That was a little bit of a beautiful song from way back when, like 1950s or something, called Secret Love. Okay, so what we're going to do is, we've got three parts of this, and the first part is what we mean by a special triangle. So, first thing is you want to know the following two triangles. The 30, 60, 90 and the 45, 45 right triangle. So this would be a special triangle. You have 30 and 60, of course, adding up to 90, all three angles adding up to 180. And the sides in any 30, 60 right triangle can be reduced into the ratio where this is 1, that's 2, and that's square root of 3. Okay, and I'll show you where that comes from in just a minute. And then the 45, 45 right triangle, you have two 45-degree angles. 45 and 45 is 90, like you would expect. And then these sides can be reduced to 1, 1, and square root of 2. So the first thing I'm going to do is show you where this comes from and give you kind of a couple of pointers on how to memorize this that are pretty logical, I think. So here's how the 30, 60, 90 right triangle is derived. Basically what we're going to do is we draw a equilateral triangle, and I've already done that. And what we're going to do is we're just going to say that this side is 2, right? Now I'm going to go ahead and just kind of sketch one, and I'll have you maybe sketch one at the side also, kind of like this. So what we do is we just start by saying every side is 2. We know an equilateral triangle is all the sides are equal. We also know all of the angles are equal, okay? But what we're doing in this diagram is I've cut it in half, see? And we call this an altitude of a triangle. So when you go straight from the top down to a bottom at a right angle, you get an altitude. And there is theorems in geometry that tell you if you do this in an equilateral triangle, then this angle of 60 gets bisected into 30, like that. So just by doing that, we get this triangle right here. All right. Now the triangle we're going to focus on is this right here, and I'm going to show you where those numbers come from. All right. So let's draw out this triangle when it's been bisected. Now let me show you kind of what we have. All we do so far is we know that's 2. We know that's a right angle, and we know that's 60, and we know that's 30. The other thing is this thing gets bisected in half. That's another geometry theorem. Maybe you learned that in high school geometry or something. That becomes 1. So just from drawing that altitude, this is what you end up getting. And then this side right here, we can just use the Pythagorean Theorem to find that. So I'm just going to say, okay, call that x, or actually let's call it like a, because that's what we're kind of used to. So the Pythagorean Theorem is a squared plus b squared equals c squared. So you'd have a squared plus 1 squared equals 2 squared. So that's a squared plus 1 equals 4. Subtract 1 from both sides, you'll get this. And then when you square root both sides, that's a is equal to square root of 3. Okay, I whipped through that pretty fast, I realize, but that's something we've done is the Pythagorean Theorem. So that's where that square root of 3 comes from, all right? So here's something I want you to think about here. If you go back to this diagram right here, let's focus on this diagram just for a minute. So what I usually say is this triangle is easy as 1, 2, square root of 3. Okay, I've heard people say it's as easy as 1, 2, 3. It's easy as ABC. There was even a Jackson 5 song that had something to do with that. So I think of it this way. 1, 2, square root of 3, and then it's logical. This is the smallest angle, and that's the smallest side, opposite. This is the biggest angle, so the biggest side is opposite like that. Square root of 3 is really about 1.7, so it's in the middle of 1 and 2, so it's opposite the middle angle. So again, think of it this way. 1 is the smallest, it matches the smallest angle. 2 is the biggest, it matches the biggest angle. Hopefully that's logical to you, and that's how I remember that, okay? All right. So now I'm going to do the 45-45 right triangle and show you where that comes from. So what I'll have you do on this one's real easy to derive this. What I'm going to have you do is let's just draw a square. Doesn't have to be perfect, but just to get the idea. And what we'll do on the square is we're going to do this. I'm going to have you just call all the sides of this square 1. Okay? And what we're going to do is we're going to get the 45, 45 right triangle. And we do this like this. Okay? This starts off as a right angle. Of course, a square has 4 right angles. So if we do what we call a diagonal, then there's a couple of things that we know from geometry that happens. The first thing is, we already know that's a right angle, but what do you think this angle is right there? If that's 90, what's logical? Yeah, 45. Same thing here. 45. Now that's proven with geometric theorems. So what you end up getting is you end up getting the 45, 45 right triangle right there. So let's just kind of move this over and focus on this. So you would end up having 1, 1, and then you would have 45, 45, and then this thing is just the hypotenuse, so you could find that with the Pythagorean theorem. So we have c squared is a squared plus b squared, so that's c squared equals 1 squared plus 1 squared, so that's c squared is 1 plus 1, that's c squared equals 2, square root both sides, that's where that square root of 2 comes from. Okay, so c is equal to square root of 2. All right, so that's a real easy derivation, and that's how, a mathematician figured these triangles out. They just came from things we already knew about equilateral triangles and squares. So you got that. Now what I want to do is I want to move up to this top thing and kind of show you how I remember this. Okay, this one just 1, 1 square root of 2, and it's logical. The ones go opposite the same angle. So there's a theorem in geometry that if you have equal angles in a triangle, then the sides opposite are going to be the same. So if that's 1, so is that, and that's logical. Square root of 2 is about 1.4, therefore it's the biggest, so it goes opposite that. So think about that, because you want to have a strategy for remembering these triangles, because they'll show up from time to time. Okay, so that will take care of the first page on that. So let's move on to the second page, and I'll show you what we're going to begin to do with this, with these triangles. Okay, and previously we've learned the definitions of the trig functions, and I'm just going to kind of remind you like this. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the opposite is, or not the opposite, the tangent. The tangent is opposite over adjacent. Okay, that's the Sohcahtoa that we talked about as a way to remember that. So it goes like this. So if we were doing the sine of 45, I'm just going to pick a 45-degree angle, and we're going to talk that out. Opposite over hypotenuse would be 1 over root 2. Right? So we would have 1 over root 2, and then we can rationalize that denominator, which I'm going to do that just kind of over at the side here. So we have 1 over root 2. You multiply by root 2 over root 2. You get square root of 2 over square root of 2 squared. So that's root 2 over 2. Now you can start rationalizing in your head if you want to. So the answer I want on this is square root of 2 over 2. All right, that's what we're looking for. And you can do that in your head. Once you practice that a little bit, you can start doing that in your head. Okay, so that gives us that. Now that means that since the cosecant is the reciprocal of the sine, then it would just be the reciprocal of how we started it. So that would be root 2 over 1. So that's just square root of 2. Okay, so that's how we do that. So you'll find that to be the case. Now what I want to do is I want to show you something on the calculator. I won't do this for every problem because it's kind of time consuming. But my calculator, I'm going to have this in degree mode. And I'm going to just go like this. I'm going to go sine of 45 degrees. Okay, it gives you decimals. Well, what did the calculator do? Well, believe it or not, the calculator did this. It did square root of 2 over 2. And then calculated that out. Actually, the calculator does something different than that. It does what's called a series, so I'm pretty sure. So anyway, see, they match up. So that's right. You can check your answer with your calculator every time you do any trig function, okay? And the way you would do a cosecant, if you do the cosecant of 45, you just do the reciprocal of the sine. So on a calculator, you could go 1 divided by sine of 45 degrees, and then that would give that. So that's the value of the cosecant. Well, that turned out to be square root of 2, so square root of 2 is the same thing. Okay, so that's how you do that on your calculator. And I just wanted to do that one time to recommend that you can always verify you're right on a calculator. Okay, next thing I'm going to do is let's look at the cosine. And the cosine is adjacent over hypotenuse. So if you look at square root of 45, the side adjacent would be this, the hypotenuse would be that. So you actually get the same answer. The cosine is 1 over square root of 2, and that rationalizes to square root of 2 over 2 like that. Okay? One thing we learned in a previous section is the sine and cosine are cofunctions. So cofunctions of complementary angles give you the same answer. And actually 45 and 45 are complementary. Okay, just kind of something I wanted to point out. Well, the secant is the reciprocal of the cosine, so it would be the same as the last problem. That would just give you square root of 2. All right, so that's how you do that. Okay, moving on to the tangent now. So the tangent is it's opposite over adjacent. So if we're doing the tangent of 45 degrees, opposite would be this. Adjacent would be that. Okay, so that's op, that's adjacent. This would be 1 over 1. Therefore, the answer is 1, so we have that. Okay, the tangent of 45 is 1. I can do this real fast on a calculator. Tangent of 45 is equal to 1. Okay, cotangent would be the same. It's the reciprocal of the tangent, so that's also 1. Okay, so that's how you're going to do that. All right. Now what I'm going to have you do is go to the 30-60 triangle, and I want to give you a little bit of time to see if you can figure these out yourself. Okay, you can write down Sohcahtoa if you need to refer to your definition. So I'm going to pause here and let you do these, and when you're ready to check, just resume the video. Okay, so you can check your answers. If you got them all right, you can just move ahead. I'm going to kind of talk through these. I'm not going to go through all of them, but I'm just going to kind of talk what we did real quick. Sine of 30, the sine is opposite over hypotenuse, so it's 1/2. The cosecant is the reciprocal of the sine, so 2 over 1 is 2. Okay, cosine of 30, look at 30 degrees. The cosine is adjacent over hypotenuse, that's root 3 over 2. And then the secant, just turn it upside down. So I do 2 over root 3. I rationalize the denominator. So that's how I'm getting 2 root 3 over 3. Try to rationalize in your head, okay? Because I'm not going to go over rationalizing too much from here on out. Just try to do that in your head. Okay, tangent of 30. Tangent is opposite over adjacent. So it's 1 over root 3. Rationalize to get root 3 over 3. Cotangent's reciprocal, and I'm just going to reciprocate the 1 over root 3, so it's root 3 over 1, which is root 3. Now when you start looking at 60, you start looking at this angle. So the cosine of 60 is adjacent over hypotenuse, so it's 1/2. The tangent of 60 is opposite over adjacent, so it's 1 over, whoa, did I do that wrong? No, I'm okay. The tangent of 60 is opposite over adjacent, so it's root 3 over 1. The cosine of 60 is adjacent over hypotenuse, so it's 1/2. Let's see, the secant of 60. The secant of 60 is hypotenuse over adjacent, so that's 2 over 1. Okay. Sine of 60 is opposite over hypotenuse. Opposite over hypotenuse is square root of 3 over 2. Cotangent of 60 is adjacent over opposite. So it's 1 over root 3, and then that rationalizes. So the key on this, of course, is knowing the Sohcahtoa and knowing how to use that. And then know that, you know, the cosecant's the reciprocal of the sine. The secant's reciprocal of cosine. And cotangent's reciprocal of tangent. That's what you do, and you have to know how to rationalize denominators. Okay, so hopefully that went fine for you. And what we're going to do next is we're going to look at what we call reference angles. And when we're doing a reference angle, I want to just point your attention to this reference angle, this diagram right here. So if you're in quadrant 1, what a reference angle is, if you're in quadrant 1, you have this angle right here. Okay, you're kind of looking at, all right, this is the initial side, like we learned. This is the terminal side, like we learned. And you're in quadrant 1. Well, what a reference angle really is what you always do is take the terminal ray and you drop it straight down to the x-axis. And then this angle here is what that reference angle is. They're going to represent in this diagram by theta prime. Okay, they're just saying theta is the original angle, the reference angle is theta prime. So in this case, if you're in quadrant 1, you're going to have the same angle. Okay, like that. All right. Now, a couple of things as I'm moving through these problems, I want to mention this, that a reference angle is always an acute angle, so it's between 0 and 90. So if I ask for a reference angle, you better make sure you give me something between 0 and 90 or it's wrong. Okay, and as I go through each quadrant, I think that'll help you understand that. Another thing is a reference angle is always positive. So if you're looking at it, if I give you a negative angle and I want you to give me a reference angle, that's always positive. Okay, so what we're going to do on the next one is like this. Okay, so you're given this angle here. Okay, that's the initial side. That's the terminal side there. So that's your angle theta. That's the original. Again, what you do is you take the terminating ray and you go to the x-axis. You never go to y, you go to x. And this thing right here is the angle you're looking for. See, that angle is an acute angle between 0 and 90. All right, so you'll in a minute we'll kind of learn how to do that. Right now I'm just trying to get you solid on what a reference angle is. If you go to quadrant 3, okay, this is the initial ray, this is the terminal ray, and again what you do is you go straight up to the x-axis, and then the angle is going to be right here. The angle is always between the x-axis and the terminal ray, and it's always acute, okay? And then the next one, your initial ray is here, your terminal ray is here. Again, what you do is you draw up to the x-axis, don't go to the y, and then the angle is always between the initial and terminal ray, like that. Okay, it's always that. So, again, what you want to know, these are real important. A reference angle is between 0 and 90. A reference angle is positive. And when you make a reference angle, draw the altitude to the x-axis. Don't ever draw it to the y-axis. That's a common mistake students make. Okay? So in your mind, make sure that you understand in each quadrant what the reference angle looks like. And another thing you can that I want to mention is we form what we call a reference triangle. And you'll kind of notice on this we have a triangle, see? We have a triangle, and then that reference angle is this angle right here. So every quadrant you get a reference triangle, okay? All right, let's go to the next thing. So I'm going to let's do one together, then I'll give you a chance to kind of do these yourself and see if you understand what's going on. So what we're going to do is we're just going to sketch the angle first of all. So 80 degrees, again, you know that you start at the x-axis. This is counterclockwise, so just estimate. Doesn't have to be perfect, just estimate a 80-degree angle. Okay, like that, and then let's sketch that as that is the angle that's 80 degrees. Okay? All right, when you do a reference angle, again, you go straight down to the x-axis. You form this reference triangle. This angle right here is the reference angle. So if you're in quadrant 1, you're going to end up with that same angle. Like it's got to be an acute angle between 0 and 90, so the reference angle is the same. Okay? All right, let's go to the next one. Okay, next one. We are going to go, again, start here. Count it out, 90, 180, you're somewhere in here. So just kind of sketch it. Okay, the angle that we're looking at, that's theta, equals 150 degrees. And again, what you need to make sure that you know is you take the tip and you draw straight down to the x-axis. And this angle right here is your reference angle. So we call that reference angle, usually we call that theta prime. And we need to think about how you calculate this. So here's the way I look at this. Halfway around the circle is 180. We went to 150. So it's just what is the difference between 180 and 150? So what you do is you subtract those two, and you'll get a reference angle of 30 degrees. Okay? You don't need to memorize a formula for finding a reference angle. You just need to sketch the angle and figure it out. What's logical? Try to learn this stuff in a logical way. All right? All right, so let's go to the next quadrant. Okay, so this is a 230 degree angle. So again, sketch your initial side, count it out. Of course, that's 180 there. This is 270 there. So you're somewhere kind of in here, all right? So let's just kind of put that kind of like that. This is your angle theta equals 230 degrees. All right, and it goes like this then. All right, so here's kind of the idea. Again, draw straight up to the x-axis at a right angle, like that. And this little angle right here is your reference angle, so we usually call that reference angle right there theta prime. Okay, now reason out how you would calculate getting that angle. Sometimes this is helpful. We know that's 180. Halfway around the circle is 180. That's 270. Well, that's not 270. That's 230. Okay. All right. So what you're doing is you're figuring out how far apart is 180 and 230. So you just do this. You do 230 minus 180 in that order. So you would end up getting, I think that's 50 degrees. Okay, so that you would end up getting your reference angle on that of 50 degrees. So that angle I've got highlighted in yellow is 50 degrees. Okay, and notice we're getting acute angles for our answer in each situation. Okay, let's do the 300. Okay, start with your initial side and sketch. So you would be, this is 270, so this all the way around the circle is 360. So you would be somewhere in quadrant 4. Okay. The angle that we just drew was theta equals 300 degrees. So it's terminating at 300. All the way around the circle is 360. Okay, I'm doing that. And again, what we've been doing is you draw to the x-axis. It's always the x-axis, never draw to y. And then you're looking at the angle between the terminating ray and the x-axis. So you figure out how to do that. So this angle here is theta prime. So what do you do to do theta prime? Yeah, you're going to do the difference between those two. You're going to do 360 minus 300 to get 60. Okay, you want to subtract it in a way that you get a positive answer. Okay, so that's your reference angle right there. Now, a lot of times students will kind of tell me, can you just give me a formula? Well, I can, but I mean, you're going to forget the formula. You want to memorize as little as possible, and you want to understand and be able to figure things out. So in this particular quadrant, if you're in quadrant 1, the original angle is equal to the reference angle. If you're in quadrant 2, then the reference angle is just 180 minus the angle I gave you. If you're in quadrant 3, then what you're going to do on this one, I'll write it kind of up here, then theta prime is equal to the angle I gave you minus 180. So those things are kind of done backwards. And then when you get to quadrant 3, your theta prime is going to be 360 minus the angle I give you. So if you want a formula, there's your formula. I mean, I just figured that out. I don't have them memorized. I just figure them out as I need them. Okay. All right, let's do a couple more, then I'll kind of put you to work a little bit. So this particular problem right here is more than one lap around the circle. And if you want to find its reference angle, you've got to kind of think of some of the things we learned how to do. So first of all, let's figure out where this angle is. One way to do this that I've taught you is just divide by 360, or not divide. Yeah, you can divide by 360, or you can subtract 2 times. Okay, you can subtract until you get an angle between 0 and 360. Okay, so that's 175. So really, what I just did is I said, okay, it's 2 laps around the circle, and then 175 degrees more. Okay, I'll review this also. The easiest way to do this to me is go 895 divided by 360. And what you're going to get is this. And what is the 2? The 2 is the laps around the circle. And then this is a percentage left over around the circle. So I usually just take that, subtract 2, and then multiply that decimal by 360 to get what's left over. So that's the 175. Okay, so you can use your calculator to figure that out. So let's go ahead and sketch this angle then. So again, like we always do, you start at the x-axis, and it's a positive angle. So we're going to do 2 laps around the circle, and then 175 more. So when I go 175 more, I'm kind of going like this, somewhere in there. Okay, so it kind of terminates in quadrant 2, it looks like. So you're going to have a angle kind of like that. All right. So, like we've been doing, same thing over and over again. You go straight to the x-axis, you get a right triangle, and your job is to figure out what that angle right there is. Okay. Well, what matters in the calculation is that angle's 175. Okay. And then halfway around the circle's 180. So what's the difference between 180 and 175? Yeah, it's 5. Okay, so you calculate this way. You say the reference angle is equal to 180 minus the angle I gave you. Therefore, that's equal to 5 degrees. Okay, sketch and reason out. Okay, let's do a negative one, and then that'll kind of give you all the, kind of most of the possibilities you'd see. Okay. All right, so we know this is a negative angle, so we know it's clockwise. I'm going to be going that way. Okay, so the way I usually do this is like this. I usually just sketch this. On the negative angles, something like this, I like to just add 360. And then that'll take care of the first lap. So you get this. So I'm just going to do this like this. What I've done on the calculator is I've just done negative 420 is really 1 lap around the circle plus the negative 60 left over. That's really the purpose of what I'm doing on the calculator is, I'm just kind of dividing it up. And what you pay attention to mostly is the negative 60. Okay, so that's the calculation I did on my calculator then. Okay, so here's what we'll do. We'll do the positive x-axis. We're going to show that we're doing 1 lap around the circle clockwise. And then we will go 60 degrees more. So where do I end up? I end up in, I did something. Oh, there we go. Okay, sometimes things screw up on this program. Okay, so I go like that. And then the angle I'm interested in is right here. So again, what I've been showing you is just draw straight to the x-axis at a right angle. And then find this angle right here. Okay, something's messed up. I need to close OneNote and reboot it. Okay. OneNote, it's a buggy program. It's a good program. It's a great idea, but it's buggy. Okay, so here's what we got. The reference angle right there would be, and just think of it this way. Now when you have a negative angle, you can just think of this as 0, and we really went negative 60. So that's a 60-degree angle, but just use a positive. Don't use a negative. Remember, you got to have a positive angle. A common mistake on that is students will give me a negative angle, but remember, reference angles are always positive. Okay, so that's how you compute them. Now, what I'd like you to do is go ahead and go to the next page. And let's see, I got these that we're going to do. So go ahead and work on the next page. And again, please do these yourself. Pause the video and then check. You'll learn more that way than if you just move on and keep copying what I'm doing. Okay? Okay, moment of truth. All right, so you can kind of look at the answers. 70 for the first, 20 for the second, 25 for the third. Number 4 does not have a reference angle. I may need to explain that. If you got those, understand, you can move on. If not, I'll give you kind of brief description of what I did on each one of these problems. Okay, 290, the angle is in quadrant 4. Okay, so I've sketched the angle. The reference angle is straight up to the x-axis. You're looking at this. You're looking at all the way around the circle, 360, minus the 290 gives you 70. Okay, again, figure out the formula as you go. All the way around the circle, less the 290. That's how I got the 70. Okay, negative 160, you got to be careful with negative angles. You're going clockwise. You will end up in quadrant 3. Again, straight up to the x-axis. You're looking at this angle right here. And see, you don't really need to worry about the fact that that's negative 160. Just think of, okay, I went 160. Halfway around that circle's 180, therefore there's 20 left over. Okay? If you have a negative angle, don't do any calculations with the negative, because you're going to get a positive answer that's always between 0 and 90. Just reason it out. If you look at your picture, you should be able to reason this out. Okay, 155 degrees. All right, I went it like this, counterclockwise, quadrant 2, reference triangle, straight down to the x-axis. You're looking at this angle right here. Okay, so this one you're just looking at the distance between halfway around the circle and 155. So 180 minus 155 is 25 degrees. Okay, what I did on this one, I just used my calculator, and this is what I did, what I've shown you. Take 900 divided by 360, you get 2.5. So that means 2 laps around the circle, and half of a lap is 180. So what happens on this one is, you can kind of see where I did my diagram. So I went, I did this okay. It's just, I did like this. So I started like this, and I did 1 lap, 2 lap, and then half of a lap. Okay, well, you end up right on the x-axis. So there's no triangle. There's no reference triangle that you can do. So you wouldn't say the angle is 0. I suspect some of you said 0 what am I doing? 0 degrees. I suspect some of you did that. That's not really right, because a reference angle has to be strictly on the interval 0 to 90. A reference angle is never 90 and it's never 0. It's just values in between. Okay, there isn't a reference angle on that, so we have a special name for this. If the angle terminates on an axis, we call this a quadrantal angle. And quadrantal angles don't have reference angles because they're on an axis. Okay, so that's the idea. I just did that, kind of decided I'd throw one at you like that and see kind of what you reasoned out. Okay, so you want to work on your reference angles, and again, you don't need to know a formula, just figure it out. I'm serious, okay? And that's the best way to do that. Okay, so let's see. Moving to the next page, we're going to use the reference angles we just learned and the special triangles to find values of trig functions. So I'm going to finish up the first part of my video by doing that, and then later, I guess the second part of my video is going to be the unit circle, which will teach you a totally different way to do this. So you aren't ever really going to have to do it this way unless you prefer doing it this way. When I was a trigonometry student, which I think was about 1983, like last century, we didn't learn the unit circle. We learned how to do it this way. And unit circle is just sort of a teaching idea that came up in my career, and I started teaching it that way. Okay, so here's what we're going to do. I do like you to know how to do this because it'll help you understand the unit circle when I teach it, where all these numbers come from. So let's go ahead and let's draw our angle. 330 degrees. Okay, that's going to be counterclockwise. It's going to terminate in quadrant 4. And draw your ray like that. May not be perfectly drawn to scale, but that's okay. All right, always draw straight up to the x-axis at a right angle. Now you need to figure out that reference angle. So the reference angle theta prime is that right there. All right, so the way you're going to do the reference angle on this is you're going to go all the way around the circle, 360, minus the angle 330, so you get a 30-degree reference angle. All right. So what we'll end up having is you want to go ahead and let's just put 30 degrees there. Let me erase that so that comes out a little better. So I'm just going to do 30 degrees there. Okay? Now, we're going to get a special triangle. So if this is 30, what is this? That's 60. Remember, these two angles add up to 90, and all three angles add up to 180. So what we're going to do is we're going to do this. Okay, the idea with this is the triangle, the 30-60 triangle, I said, is easy as 1 to square root of 3. Okay? Easy as 1, 2, 3. It's as easy as A, B, C. I always think of that Jackson 5 song, which was popular about 1970 when I was a kid. Okay, well, here's what you want to do. All right, the 1 goes opposite the smallest angle. Now, this is going to be a y value, so you're going to use a negative 1. So it's like y is negative 1. You're kind of looking at this point right here. So it's down negative 1. Okay? And then this point here, opposite, so that's the 30. Opposite, the 2 is the hypotenuse. That's the biggest. So 2 goes there. And a hypotenuse is always a positive number. And then this would be the square root of 3, and it's an x value. Okay, so you're going over and down to get to the terminating ray. So it's positive 3, negative 1. Okay, that's all you got to do. That's the diagram. Now we can figure out the trig functions from this. All right, so again, this is just your Sohcahtoa stuff. Okay, so what we end up getting on this is the sine. If you look at 30 degrees, and just look at that, look at 30 degrees, you're going to have opposite over hypotenuse. Okay, so therefore, the sine is negative 1/2. Okay, again, look at 30, look at the reference angle, opposite over hypotenuse. The cosecant is the reciprocal of the sine, so that's just negative 2. All right, so that's how you would get those values like that. Now again, I'll do this one time just to stress that you can, if you're doing homework and stuff, you can do this. So we have the sine of 330 is equal to negative 0.5. So that matches. Okay, the cosecant, you would go 1 over the sine of 330. Okay, it's the reciprocal. The reciprocal is 1 over that value, so the cosecant's negative 2. That's what you do to check your answer. Okay. Okay, now we'll do the cosine. So the cosine is adjacent over hypotenuse. All right, so what we're going to have is adjacent is square root of 3, hypotenuse is 2. So that will be adjacent over hypotenuse. So that's square root of 3 over 2. Okay, how do you find the secant? You do the reciprocal. So it's 2 over root 3. Rationalize the denominator. You may do that in your head. You would get 2 root 3 over 3. Okay, like that. All right. Let's see. I think I made a mistake here. I think I meant for this to be tangent. And I meant for that to be cotangent because I don't want to repeat myself. Okay, so tangent is opposite over adjacent. Look at your triangle. Opposite is negative 1. Adjacent's root 3. So opposite over adjacent is negative 1 over root 3. If you rationalize that denominator, you're going to get negative root 3 over 3. I'm not going to go through the details of rationalizing much anymore. Okay, the cotangent is the reciprocal, so I would reciprocate here. So I would have negative root 3 over 1. It doesn't matter where the negative is. It's just a negative answer. So you have that. Okay, so that's how you do that then. And again, all these problems are checkable on your calculator. All right. Okay, so you do the reference triangle and then do your trig definitions. Be very careful about what x and y is because x can be positive or negative. Y can be positive or negative depending on where you are and what quadrant you're in. Okay, let me go to the next one. Okay, so let's go ahead and let's start and draw our angle. So 225 is in quadrant 3. So I'm going to draw that like this. So our angle theta is theta is 225. Okay, the reference angle, where do we draw? Do we draw to y or x? We draw to x, always. Okay, so we got that. The reference angle is this guy right here. So that's what we need to figure out, is that reference angle I call theta prime. Okay, all you're doing is that's a 225 degree angle here. Halfway around the circle is 180. You're just looking at the difference between those two numbers. So the reference angle theta prime is just what 225 minus 180 is. Okay, that's 45. Okay, 45. Now see, the reference angle on these problems is always going to be either 30, 45, or 60, because otherwise you couldn't do the problem this way. All right, so let's go ahead and let's kind of fill that in now. So we have this reference angle, so I'm going to go ahead and just throw in, I'm going to erase a few of these things here. Okay, so what I have on this is I have this angle is 30 to, not 30, what did I get? I got 45. Okay, so this angle right here is going to be 45 degrees. This is your right angle right there, so that is also 45. So you have the 45, 45 right triangle. The sides on this go 1, 1, square root of 2. Okay, and it goes like this. Okay, the ones go opposite the equal angles 45. So when you go this way, this is going to be a y value because you're going down. So you'd say y equals not 1, but negative 1. And then this side of the triangle, not 1, it's x is negative 1. Okay, just think of it this way. You're going left and down. Okay, this has a point on it right here. There's a point on that terminating angle. All right, so we have that, and now we're ready to do this then. Okay, so let's go ahead and let's work through these then. Again, look at this 45 degree angle, look at your reference angle, and do your Sohcahtoa. So sine is opposite over hypotenuse, so that would be opposite, and hypotenuse is 2. I forgot to write that on there. Okay, because remember it's a 1, 1 square root of 2 triangle. Okay, so what you would get here is opposite over hypotenuse, so that's negative 1 over root 2. If you rationalize, you get negative root 2 over 2. Okay, so that's the answer. Okay, the cosecant, you can go like this if you want to. The cosecant's hypotenuse over opposite, so that would be negative root 2 over 1, or just negative root 2. It's the reciprocal of the sine, see, so you get that. Okay. Okay, so now we're going to look at the cosine, and the cosine goes like this. The cosine is adjacent over hypotenuse. Look at 45, adjacent's negative 1, hypotenuse is root 2, so we get exactly the same answer that we did on the sine, and that shouldn't be a surprise because these are cofunctions. Sine and cosine are cofunctions, and the complementary angles are 45 and 45, so they're the same. Okay. All right, and then the secant's the reciprocal, so you would get also just negative root 2, like we did on the previous problem. All right, and then this was intended to be, I think, tangent and cotangent. Okay, so we want to do that. And it's going to go like this. Tangent is opposite over adjacent. Look at your diagram. Opposite's negative 1, adjacent's negative 1. So this is really negative 1 over negative 1. So it's equal to positive 1. Okay, you have a negative over a negative. Same thing here. If you do the reciprocal of this, obviously you get the same. It's just negative 1 over negative 1. So its answer is 1 also. All right, that's it. Okay, and just real quick, just a quick reminder, if tangent of 225 is equal to 1. Calculator will verify your answers for you. Okay. Okay, and you may be asking, why can't I just use my calculator? Well, your calculator isn't going to give you square root of 2. It'll give you negative 1.4 and all those decimals. We want everything precise. That's why. Okay, so let's see. What I'll have you do is just one problem. Just go down the bottom, pause for a minute, and pause and check. Okay, and then this will be the end of part 1. going to do the video in 3 parts on this to kind of break it up into the 3 main items. Okay, go ahead and pause. Okay, let's check your answers and let's see if we're doing this okay. So you should have got square root of 3 over 2 and 2 root 3 over 3 for the sine and cosecant. I'll explain that in a minute. If you got the right answers, then you can close the video and you're good to go. Cosine, negative 1/2, secant, negative 2. Tangent, negative root 3. Cotangent, reciprocal, negative root 3 over 3. So the key thing on this, if you didn't get these, is you draw your 120-degree angle. You want to make sure you drew that. And then you want to make sure you figured out that reference angle. The reference angle is 180 minus 120 is 60. That forces you to have a 30-60 right triangle. And then the sides, remember I said easy as 1, 2, 3. It's as easy as A, B, C. I should get my guitar out. So anyway, it goes like this. Okay, the 1 goes opposite 30. The 60 gets the square root of 3. Hypotenuse is 2. You got to know how to match those things. Okay, that's the one that goes with the small angle. And then the 2 is the one that goes with the biggest angle. And the square root of 3 is in the middle. Now, you got to watch the signs. I wouldn't be surprised if some of you maybe made a mistake on the sign. So you're going left and up. So x is negative. You're in quadrant 2, so x is negative, and you're up, so y is positive. Okay, then it's the Sohcahtoa. So the sine is opposite over hypotenuse. So you want to focus on your 60. So opposite over hypotenuse. Square root of 3 over 2. All right, then do the reciprocal for the cosecant. The cosine is adjacent over hypotenuse. So again, adjacent, negative 1, hypotenuse 2. Negative 1 over 2. Secant's reciprocal, so it's negative 2. Tangent is opposite over adjacent, so that would be opposite, root 3, over adjacent, negative 1. Root 3 over negative 1 reduces to negative root 3. Then I did the reciprocal, and I did the reciprocal of root 3 over negative 1, like that, and then I had to rationalize denominator, okay? So that's it, all right? So that will take care of the first part, and hopefully that's a pretty detailed video, and that'll help you understand the concepts. All right, good luck.